So, yeah. So what's our degrees of freedom? What's our degrees of freedom?
Oh, the number minus one.
The number minus one. What number minus one?
The count, whatever the 41 minus 1. Is this 41 nurses? No?
Oops. Okay, so the count minus one, so there's 41 in the sample, so it would be 41 minus one, which would be 40. So my degrees of freedom is 40. So what's the test statistic?
40.
T. And then I have to calculate it. But see, this is where I go back. It doesn't really matter what I call the test statistic. The test statistic is still the mean of the sample minus the mean in the hypothesis divided by the standard error. But since we don't know the standard error, we don't have the sigma, we are going to use a estimated standard error. How do I calculate the estimated standard error?
26. That's that.
What's that?
That is the sample standard deviation.
The sample standard deviation divided by the square root
the
of
count.
n. So I'm going to go back, I'm going to pull up my Excel spreadsheet. Again, I'm not using T, I'm using Z. My n was what?
41.
41. What was the sample mean?
Sample mean.
71,121. What was the standard what was the sample deviation?
7,489.
7,489. Did I have a population deviation?
No.
Unknown. That's why we're using the t-table. Okay. What was my mu? What was my null hypothesis?
69,110. Yeah.
So 69,110. And then my alternative hypothesis is that it was
Less than or equal to.
greater than.
Oh, yeah, greater than,
You
right?
never have an equal sign in an alternative hypothesis. The equality statement is always in the null hypothesis.
Oh. Oh, yeah, that's right. All the
Okay.
followers have that.
Test statistic. Okay, I still take the sample mean minus the mean given, and that has to be in parentheses. You see, I forgot to put it in parentheses when I first started to type it. Divided by the standard error estimate. So I'm going to come down here, and I don't have my standard error estimate, right? So I'm going to have to calculate that. So how do I calculate the standard error estimate?
Oh, that's the sample
The sample
Standard.
deviation
divided by the square root of the count.
divided by the square root of n.
Okay, so that's the mean. Minus the
Okay. Now, the p-value I have to redo. Because this p-value is based on what? The normal table, but we're not using the normal table, right? We're using a t-table. Okay? And here's where I don't like using p-values when it comes to t. Because it's harder to calculate. I'm going to go back and I'm going to draw my picture. My t-table is still going to look at that. My mean here was what? 69,110.
yeah.
And the value that we got was what? 71,000. What was it?
121.
121? Okay. Did they tell me what out now? Our alternative hypothesis was that the mu was equal to 69,110, and my alternative hypothesis was that mu was greater than 69,110. What was my alpha? They gave us an alpha, 5%, which is the default. If they didn't give it to us, that's what we would use. Is it one-tailed or two-tailed? One-tailed. Whoops. So that means all my alpha goes in one tail. So that means I want to look up a t-value that has an alpha of 0.05 and degrees of freedom of 40. So I go to my t-table and I look that up. So now, this gets to be a little bit tricky. This is 0.05, which means that this is what? 95. So see, when I'm looking at my t-table, what I want to do is look at I'm going to look up here and see here where it says, this is where I always have to think about it. It says cumulative probability. So that means I want to work with the 0.95, not the 0.05. But down here it talks about my alpha of one tail. And you see here where it says 0.95?
Yeah.
Under here it says one tail, and it's got my 0.05. So see, this is my alpha that's tied to that value.
Okay.
So it sort of gives me both values.
Okay.
So I'm going to use this column, and I'm going to come down to the degrees of freedom, which is 40, and I get what, 1.684? So I get a table value of 1.684. So now we go back, and we already calculated it. So my table value is 1.684. What's my test statistic? 1.71. So here's what I do. Remember when we just said this? I compare the absolute value of the test statistic, which is 1.71, to the absolute value of the table, which is 1.684. And that puts me, so if I did that and I'm looking at the table values, my calculated test statistic is 1.71.
But-
Where does it live? Does it live in the meat of the table or in the tail? It lives in the tail. If it lives in the tail, I'm going to do what?
Reject.
Reject. I'm going to reject the null hypothesis. So I'm going to reject that the means are the same. That the mean of this California sample is the same. Therefore, I'm going to accept that California nurses get paid more on average than the rest of the nation.
Can you show me what you chose for your test statistic? Now it said that we're supposed to get that would have been the mean, which is the 60. No, I'm sorry. Would be the X bar, which would be the 71,121 minus the 69,110.
X bar, which was 71,000 what?
121.
121 minus the mu, which was was what? 69,110 divided by the standard error estimate, which was 7,489.
Okay, then I did something wrong with that one.
Divided by.
Okay, so I did the.
Oh, okay. She didn't give me the standard error. She was looking at this and saying my standard error estimate was, what was that?
7,489.
7,489
Isn't it divided?
divided by the square root of
Oh,
41,
okay, so I did that.
which gave you what?
1169.58.
1169.
9.585.
So that's what goes here, 1169.
585. Okay, so when I did that, I get a test statistic of 2.
Well, you have to use that number and then minus it from the top part, or divide it from that part.
Oh, I
And
guess
then-
it rounded it. It rounded it. So I got 1.7194 when I
Yeah, so
figured-
we-
You
okay.
gotta be careful, again, rounding error, if you round too soon, which is again why I use Excel to do the calculations.
I'm not getting my p-value right. It's not saying that it's 1.68.
So what did you-
Well, that's
What
because
do you
you
think
can't
it
get a
is?
p-value from a
Huh?
t-table.
Oh,
So
Remember I said it's much easier to get a p-value for a z than it is for a t? About the only way to
I
get
would
a,
try 1.72.
you have to use
Because it's
Excel to
two.
get a p-value for a
Oh no, rounded to
t-table.
3. Rounded to 3, so 71
So that's why I normally don't compare the p-values in
Nine.
alpha.
was mine.
I normally compare
7.9?
the calculated test
Just
statistic to
7.9.
the table
Okay,
value.
1.71.
Because I have all that.
I missed that part.
Well, it says to round to 3, that's fine.
So,
If we're using the T table.
So to get my p-value,
Yeah.
I have to type in, I'm going to a t-table, and I want a distribution, I would hate these, for a right tail, and my x is, what was my x, 1 point? Was the calculated test statistic,
Okay, what?
and my degrees of freedom was 40. So I get a p-value of 0.04. I have to use Excel to get the p-value.
The degrees of freedom was 40, right?
Yes. And you use the test statistic as the X value. And again, if the p-value is less than alpha, you still reject. So you still have to make the same decision. It still comes down to,
The p-value is less than the alpha.
I thought I wrote that someplace.
The p-value is less than the alpha.
If the calculated value is greater than the table value, you reject. If the p-value is less than alpha, you still reject. And you can see that when I got the p-value here, the p-value is what? 0.4, which is less than 0.5. So both ways I make the same decision. You'll make the same decision both ways every time. So I can either compare the calculated test statistic to the table value. It's easier to find the table value than it is the p-score or the p-value.
I'm doing something wrong. Okay, so how did you get the p-value? You put the norm S distribution?
No, because norm refers to the normal table, which is the
Oh, T.
Z table.
T.
So in this one, we're using the T distribution, so I'm going to put in
P-value?
T. And this is a right tail test. See, with the T table, you have to use to tell it whether it's a left tail test, two tail test, or right tail test.
Okay, I see this.
So on your sheet, if you're using Excel, you want to know what form, you need to know that it's T distribution, right tail T. See, this is why you have to be able to identify it. That's why I first did the first part. Let's do one more.
How do we get?
Oh my gosh.
Okay.
I get bits and pieces of it.
Let's do number 11. So number 11, the statistic instructor claims that 60% of the students who take her elementary statistics class go through life feeling more enriched. For some reason, she can't quite figure out, most people don't believe her. You decide to check this out on your own. You randomly survey 64 of her past elementary statistics students and find that 36 feel more enriched as a result of her class. Now, what do you think? Is this a mean or a proportions?
Proportion.
Why do you think it's a proportion? Because it feels that way.
Well, there's
average.
I love it.
There's no wording of anything to do with
Yeah,
averages.
there's no wording that says average, so it doesn't seem like we're talking about average. And what are we talking about? We're talking about 36 students out of 64, which sort of thinks about a proportion. Okay? So this is a proportions test. So if I'm looking at this, I have to go back and it's a proportion. Now some questions that I asked with a proportion. What was the N of the sample? 64. They asked 64 people what they thought. How many thought they were enriched?
30.
Was it 32? 36.
30, yeah.
Okay.
Which one is how many? 30, the red number?
Yeah, it's the number of students who feel more enriched.
Okay.
The number of students that feel more enriched. What's my null hypothesis?
Um,
My null hypothesis is that the proportion is what?
Greater,
Close.
greater and equal to.
Greater than or equal to what?
61.
What was it that she was claiming?
60%.
She claimed 60%, right? So that's my null hypothesis, 0.60, which means my alternative hypothesis is what?
It's less than 60.
That's not
I mean,
you.
Oh, the P.
The proportion
proportion
is less
is-
than 0.60. Because you don't believe her. You think she's blowing smoke. Okay. What distribution do we use?
The T table.
No.
No?
Good guess, but you're wrong.
Really?
Z table.
Z table, yeah, proportions, we always use Z.
But we don't have the
Proportions, we always use Z
proportions.
for, in this class.
Always use the table, even if we don't have the standard deviation.
Well, you won't have a standard deviation because you don't have a mean, and the standard deviation measures how far the mean is away from the, or how far the value is away from the mean, right? So we don't have a mean, so we're not going to do that, so we're using something that approximates that. So it is a normal distribution or a Z distribution. Okay. Now, what is my P prime?
mm,
It's a proportion. What proportion do you think it might be?
The 95%?
No, it's the proportion of the
64, 30,
sample that
Oh,
feels
right.
enriched.
34 out of 64. or-
So it's going to be
36 divided by 64.
36 divided by 64.
Yeah, coming back to me now.
What's the Q that's related to that?
1 minus that. 30. Yeah, 1 minus that number.
Okay. Now, I have to be able to calculate a,
Standard error estimate.
it's not gonna be, it's not really a standard error estimate, it's an actual standard error.
Really?
Yeah, because we're not dealing with means and standard deviations of the sample, we're just dealing with the different aspects of that. So we calculate a standard error on this.
Wait, what is the P prime? I thought it was,
The P prime is the proportion from the sample.
so it's 36 minus 64.
No,
Divided by
the 36 is a proportion. So it's a and then the Q is 1 minus that. So standard error for a proportion. Abby, you should know this. Yes, you do.
Abby.
You know this. You gave it to me earlier.
I did.
Yes,
I.
The sample.
she gave it to me before you walked in, I think, too.
The sample.
No, it's not on the board, you're not gonna find it looking on the board.
What is that?
You're not
Oh,
gonna
that's
find it
the
looking
S.
on the board, because that's all doing with means.
I gave it to you.
Yeah,
I can't remember. Oh, the P minus the Q.
close.
Times the Q.
P times Q
Divided by
Thank you.
the count.
divided by
Minus.
N.
Yeah. Okay, right.
Okay, now the question is, what P and Q do we use?
No, which is
And this gets to be the tricky part, okay? Because we've got a proportion here from the sample of 0.56 and a Q of 0.4375. But when we do the calculation for the standard error, we go back to the proportion of the hypotenuse, which is 0.60. So what would be the Q related to this?
Okay, what? How come we can't just use the regular P?
Well, when you calculate the standard error, you don't use the proportion from the sample.
We need the proportion.
You use the proportion that's stated in the null hypothesis.
Divided by
Oh.
N.
So the P in the null hypothesis is 0.60.
Square root,
Oh,
yeah.
wow.
So the Q related to this would be,
1 minus the 60, so 1.40?
would be 1 minus the 0.6, which is 0.4.
Oh, that's complicated.
So this is going to become the square root of 0.6 times 0.4 divided by
The 36
There.
or the whole 64?
the n, the 64.
Oh my gosh, that's gonna mess me up major.
It's n is always to count as a sample. 36 were the ones who thought their lives were enriched. It was not the size of the sample.
Oh, man, I don't know how to
This
get
is
back to you.
ridiculous.
I don't know how to get back to you.
Yeah, like how would I
Just
know
lost.
this?
How do
So
we
when
get
deal
the
with
point four?
proportions, standard, see, this is where I keep saying, you have to know what you're dealing with, and standard error, the calculation for standard error changes for each different type of test. Whether if it's means, we have to know whether or not the standard deviation of the population is known or not. That gives us two different ways to calculate it. That's what's up here. If it's a proportion, this is how you calculate the standard deviation, or the standard error. Not standard deviation. So, equals square root of this times this divided by 64. I put an extra parenthesis here. So I get a standard error of 0.6123. How do I calculate my test statistic? Still the same way.
No, I'm just getting stuck on silly things. Like, I never saw you put the 0.6, so I'm stuck on where did that come from?
On the 60%?
Yes.
60%.
It's just, that's just what, okay.
I'm getting an extra
Standard
zero.
error.
What do we have for standard error? It is
Right
the
there.
square root
See, she made a
of,
claim 60%,
that's
right?
60%.
But when we're dealing with a
40%
proportion, we're not
divided by
going to
the
write it as 60%.
Yes,
We're
okay.
going to convert it to the decimal
What do you have?
0.60.
Okay.
count. I have
And that came around
Six,
the
one, two,
statement,
three.
that she's
Okay.
believes 60%.
And you got 40 because it
Because,
has to be out of the whole, which is 1, so you do 1 minus 0.6.
I don't know how I get the first
And
P.
where is that
I got P
supposed to go?
prime.
that's
I don't
just
know-
your
I don't
Q,
have
P and Q are always related, they always have to add up
So you
to
get a P
1.
from this, right?
Okay, so
You
that
said-
would be 0.60.
When you look at the proportion, we're not gonna write it as 60%.
That's what that's what P
That
stands
that's
for?
what the P would be, that they're.
Yes.
The P would be 60.
You
the
cannot
20,
calculate
they're
with percent, you always have to convert it to a decimal or a fraction.
Yeah.
So Q- if I go
For the
here,
claim, for the claim, not for the actual proportion.
yeah, so if I go for Q, let's call this the Q for
And it
this.
is
I'm
actually
gonna
zero.
do equals, 0 point
No, just put
That's
one
not point,
minus.
it's 60%, not 6%.
1 minus 0.060.
No, 1.06.
How do you think I'm going to calculate the test statistic?
Their claim is 60%.
X
Yeah,
minus the
0.94.
mean of
No, it
the
should be 40.
hypothesis divided by the standard error.
Close.
One
Oh.
minus
I am
0.60.
going to divide by
So
standard
turn
error.
60% into a decimal.
But I don't have means.
Oh. So, would it be this,
So just type in 0.6.
What am I testing? What am I
So
testing?
fast.
I'm not testing means, I'm testing
Proportion.
proportions. So I'm going to be subtracting proportions.
So P minus. Q.
Remember when we were testing means, we took the mean of the sample minus the mean from the null hypothesis, right?
So is it just P minus?
So this
Q?
is proportions, I'm going to be taking, my numerator is going to be the proportion, so it's going to be a P, which P is it?
How about the
P
population?
prime, which is the proportion from the,
Okay.
what's P prime?
The population.
No,
No.
guess again. If it's not the population, it's
The sample.
Sample. It's the proportion of the sample minus
So there's the proportion of
the
the claim.
proportion, which we got from the
Claim.
from the hypothesis.
The
It's the
hypothesis.
0.60.
So we're gonna call it hypothesis prime, and we're gonna call it prime prime of the sample.
proportion of the sample?
That, if that's what can
P
help you
prime
get
is
this straight.
proportion of the sample. Sample, yeah. And P, minus the P is
The proportion that she was projecting, the 60%.